Okay, we are starting recording this lecture. So, good morning, everyone. Just checking. Can you hear me? Can you?
Yes.
Yes.
Oh, okay, good. Okay, so let's go on the lecture slide. Can you see the lecture slide?
Yes.
Yes.
Okay, so from time to time, I'll be asking a few questions. So do those who want to answer, you unmute yourself and then you answer, and then you can again mute yourself. So I would like to have answers from you as well, so as we can have a good lecture. So you just recall from last week, I introduced to you what is this IoT, the IoT ecosystem in general. What are the different components it consists of? So we will wrap up this discussion today with IoT. My main theme is the IoT ecosystem, presenting to you the different components of such a system. And then in the course, as from next week, we are going to take each part of the IoT ecosystem and explain it in detail. Okay. Just letting you know also that we will have a lab session this week on Thursday morning. So I will discuss about the lab session by the end of this lecture. Okay, so let me take it from where we left it last week. So we were discussing about this IoT ecosystem. So I have told you that the IoT normally system consists of the sensors, the below layers, and then you have all the networking, the data, the communication, and then you have the information processing, and at the top, obviously, your application. So, and one of the most important component of any IoT system is the microcontroller board. Okay, it is a computer that we use in our IoT system. So it is also called micro electromechanical system, MEMS. Okay, and I've told you last week that the microcontroller board that we are going to use in this module is the Arduino. Okay, I mean, now Arduino, the different version of Arduino, the one of the very popular version is Arduino Uno. So we have a few Arduino Uno that we'll be using in the lab as well. But note that we don't have only Arduino, we have many other board from Intel, Raspberry Pi, a BiggerBone. So all these are a example of microcontrollers. Okay, and in the lab, I can tell you also one of our main discussion this week will be on microcontrollers, because this is one of the main component of any IoT system. So I will introduce you to microcontrollers, and then you will also have a lab assignment on microcontrollers. So I will discuss it slightly later. So do keep in touch with respect to all your assignments, because all the assignments will be marked in this module. Okay, so this is the kind of lab that you will have to do in the following weeks, not now. I need to introduce you to two main things before we can start doing building our circuit. First, the microcontroller itself. What are the different components of our microcontroller, the Arduino board? Second, we will have to learn Arduino programming. Okay, so how do we write an Arduino program? So this I'm planning next week in the lab to introduce to you the Arduino programming in one lab only. So you will learn how to write Arduino program. So if you know programming in Java, you know programming in C or whatever. Okay, so you will see the syntax slightly different, but at the end of the day, it's, writing an Arduino program is a very easy task. It has only two functions there that you need to write your specific code. I'll give you sample code as well, don't worry about it. So you need these two building blocks, that is knowing how to handle your microcontroller board and then writing the corresponding program. So last week also, this I've already covered with you. We have other building blocks that we have in an IoT system, have the sensors and the actuators. We are not going to work with actuators for the time being. We are starting mainly with sensors. So sensors basically to read something from the environment. It sense from the environment. It can sense humidity, temperature, motion, position, proximity. So you can have all these types of sensors. And actuators, these are devices that perform something in the environment, opening a door, closing, opening an air vent, things like this. So these are done by actuators. After you have so many sensors are already available in the market. So, and also the price for the sensors have been going down a lot. Some popular providers of sensors. So you have Adafruit, Sparkfun, Liberium. These are some popular providers of sensors. I think this is somewhere where we reached last week. So I'll refresh you on a few slides and we'll continue now. So one of the main component of this module you will note that it is about the IoT protocol. So it's not only getting a few sensors together, connecting it with your board and transmitting data. Behind, there are a number of protocols that are used, that you need to know those protocols and need to know how to use those protocols. You will be exposed mainly to two types of protocols. One is for the infrastructure, for the data, for the networking part itself. And so you have identification, communication. So obviously the communication protocol, whether you are transmitting through Wi-Fi, through Bluetooth, or low PAN, wireless PAN, 802.15.4 mainly. Otherwise, one of the main protocol that you are going to use, that you need to know how each one works, is data protocol. At the end of the day, if you don't know how to manipulate those data protocols, you won't be able to capture your data and to set when you need to read every 5 seconds, every 15 seconds, and how to capture those data and how to manipulate the data. So you will need to familiarize yourself with data protocols. So we have a long discussion about data protocol. If I'm not mistaken, it is in the second semester. For example, we are going to discuss about MQTT, COAP. These are protocols that we are going to study in this module, and you will also be examined on those protocols. So basically, you have a number of protocols that you will need to familiarize yourself in order to be able to implement complete IoT system. Let me continue. So you can see again here the IoT protocol stack. So below on the lower level is a physical layer. So at the physical layer, so what kind of technology are we using? So most often you will see here IEEE 800.15.4. You can see down. So most IoT devices, they use this protocol, IEEE 800.15.4. Just like you have Wi-Fi use, it is IEEE 800.11. Okay. Most of your sensor devices, they are not Wi-Fi enabled as such. They use instead IEEE 800.15.4. Can anyone tell me already? I can put a question to the class. We are discussing about the physical layer. At the physical layer, what type of technology do we use? You see a number of technologies down here. You have IEEE 802.15.4. You have BLE, Bluetooth Low Energy. This is again becoming increasingly popular in IoT system. You have Wi-Fi, which is there, but most often we don't use Wi-Fi. You have NFC, which is again a popular technology, near field communication, and 3GPP. So most often we use this one, that is IEEE 800.15.4. My question to you is, why this one? Why IEEE 800.15.4? Why not, for example, most often we go for Wi-Fi? Because Wi-Fi is so widespread, we use it a lot. Most of our other devices, like our laptop, our mobile phone, are already Wi-Fi enabled. Why not for the sensor devices, small sensors, your microcontrollers, whatever? Why it is based on this technology, on this physical and data link layer, and not Wi-Fi? Okay, so I'll listen from you if you ideas from your side. Yes. Why not Wi-Fi? Why IEEE 800.15.4? And what is this IEEE 800.15.4? Why it is more suited for IoT devices? I can't hear anything. Try, and even wrong answer, no problem. At least try.
Why sensors do not use TCP/IP?
Yeah, last week I think I mentioned something about. Let me see if someone wants to join the class. I heard something. Okay. Yeah. Okay, we have received 2 more students who have joined the class. Yes, your friend just mentioned just now that IoT system. Last week, I think I mentioned that IoT system are not based on TCP/IP, which is true, but this is not the reason why we use IEEE 215.4. Actually, this is the problem it causes. The problem it causes is that it is not TCP/IP enabled. I cannot transmit directly to the internet. Even if we call it Internet of Things, IoT, Internet of Things, actually we cannot connect to the internet. Your IoT, your sensors, they cannot connect to the internet normally. But what makes them connect to the internet? Everything we are going to learn. So the question that I've just put to you, if we were using, so specifically, your friend just mentioned that, yes, it is not TCP/IP. But if we would have used Wi-Fi on your mobile phone, you can directly connect to the internet through Wi-Fi, you know? So this would have been very easy. Just like on your mobile phone, you can connect through your Wi-Fi, you can connect to internet. Why not use Wi-Fi in all our sensors and then we connect to the internet directly? So this would have been a good solution, but no, we can't do this. The reason is why.
Maybe I can try another. Sensors do not send large amount of data.
Okay, so your friend saying that last week we have mentioned that sensors normally don't transmit large volume of data. Instead, it transmits very small amount of data, but frequently. Yes. So again, no, I don't think this is the reason, because even with Wi-Fi, we could have sent very little data. So no problem with sending little data frequently using Wi-Fi. So why not Wi-Fi? Why we need to use IEEE 802.15.4? I will tell you in a few seconds what is this IEEE 802.15.4. Most of your IoT system, they use this one. This is why I'm stressing on this one in the very beginning in introductory lecture on IoT. Okay, and other students, be active.
Maybe it's because it uses less energy and it is less costly.
Okay, now we are coming to the point. Yes, indeed. One of the main reason why we don't use Wi-Fi, okay, because still Wi-Fi is greedy in terms of energy consumption. See, your mobile phone, you power it every day, no? Your mobile phone. This is why you are able to put your Wi-Fi on and everything. Okay, even Bluetooth consume quite some amount of energy. This is why there is I don't know whether you have met this version of Bluetooth low energy, Bluetooth 4.0, actually it is known as BLE, which has been specifically designed to consume less energy. But even BLE consumes some amount of energy, which is slightly higher than we require for our very small energy constrained IoT devices. So yes, one of the main reasons your friend has just mentioned is a matter of power consumption. It's a matter of energy, because our sensors need to operate in the environment for not days, not weeks. We want our IoT system, once I have deployed them, they work even years, okay, without us having to go and change battery. So this becomes very challenging. So I cannot go and change battery every day. I cannot power those devices every day. They need to last for months and years. So this is why we don't use these common technologies like Wi-Fi and everything, because those technologies, they are greedy in terms of energy. This is why IEEE has come up with what is called low power technology. Okay, that is IEEE 802.15.4. So Wi-Fi, it is IEEE 11. Okay, 802.11. This is Wi-Fi. Okay, whereas we are talking about a IEEE 800. As soon as you see .15, 800.15, the .15 means low power. You associate the idea of low power to all technologies that normally follow .15. Actually, Bluetooth is IEEE 800.15.1. Okay, which is still low power, but 800.15.4 is even lower in terms of power consumption. And most devices that you're going to buy, IoT devices, sensors, and everything that you're going to buy, they don't have Wi-Fi, they don't have Bluetooth. Most often they will have IEEE 800.15.4. This is why as IoT students, as sensor system and application student, you will need to familiarize yourself a lot with this IEEE 800.15.4. This is mandatory for you because this is a protocol, this is the technology. It is not a protocol, it is a technology that we are going to use most often. Now, this is an issue last week I mentioned to you. IEEE 800.15.4 is not, we cannot connect to the internet with it because it doesn't work with TCP/IP. This is an issue I mentioned last week. We are using IEEE 800.15.4, which cannot connect to the internet. Wi-Fi can connect to the internet. This is why on your mobile phone you connect directly to the internet. So you will see eventually how do we resolve. You notice on the diagram already you see the solution here. So you see down here I see 800.15.4. Most of our sensors use this. What allow our sensors, which uses this technology, to connect to, you see on this layer, transport layer, TCP and IP above, okay? You see here TCP IP. What do you think make the link between our sensors, which use 800.15.4 and internet eventually? There's something in this diagram. Let me see if you can spot this, this thing that do the bridge between my sensors, low-level sensors, IEEE 800.15.4 with TCP IP. Anyone? Again, not the same student, if possible. Others, be active.
I think it's the 6LOWPN.
Exactly. You see where it fits. Anyway, you see on the diagram here. Exactly. So you see 6 low wireless PAN. This technology, it is we can say it is a protocol. Yes, we can say it is a protocol. This 6 low wireless PAN technology, its job is to do the mapping from 800.15.4 to eventually whatever we use on the internet, TCP IP. So very good. So this part here. So this is why in this module we have one complete lecture where we are going to discuss about 6 low wireless PAN. What is its job, how it do it, how the packet size is transformed and everything. So you will have to learn about all this. So you see, this IoT thing is not only about getting a few sensors, putting it together. There are a number of challenges, technical challenges that you will have to learn how to overcome. And this is my purpose here in the different lectures. In the lab, it requires just a few lab to make you connect a few sensors, transmitting the data. But I don't want you to learn only this. You need to learn what is behind, what is the infrastructure behind, what are the technical issues we have, and how do we overcome those issues. This is why in my very first lecture slides, okay, I'm already presenting to you this whole ecosystem. You see, most of our sensors use 800.15.4. Then it goes through this 6 low wireless PAN. Then upper layers you see TCP IP. Okay, we use HTTP and everything. But then at the top here, you notice COAP. This is for the data management. Over the internet, for you to get your web page or whatever, most often at the data level, we use what is called HTTP. But unfortunately, again, for our constrained devices, for our IoT system, we will not be using HTTP for manipulating, capturing our data and storing our data. We don't use HTTP. Instead, we have other data protocol that we use. COAP is one of them, Constrained Application Protocol. We have MQTT. We have XMPP. All these we are going to cover in this module. You see, and you will have to know how those protocols they works, how they exchange data, what are the steps, the sequence diagram for each one will be given in this lecture. So this is why learning about IoT is learning all these, not only getting a few sensors, connecting it with your board and transmitting the data. So there will be a number of challenges. So let me proceed. So this is what is called the IoT Protocol Stack. At the end of the day, after completion of this module, you will come to know about everything that we have on this diagram here, up to the application when you're using the data. At the application layer, we are using the data. Below physical layer, we are producing, capturing the data. And in between, you have the networking, the transport that happen. Okay, let me proceed. Okay, this is a big picture of our IoT system, the hardware platform. You can see previously I've shown to you in terms of protocol, it is like this. In terms of hardware, actual system, it will be like this. Okay, so at the here at the top is my we have my devices. Okay, the devices. So you have sensors connecting to a board or whatever. So those sensors, those boards to communicate to each other. Here we form what is called a sensor network. But when they communicate with each other, it is still local among the different sensors they are communicating. They are not communicating to the internet, but somehow at the end of the day, they need to connect to the internet. So we use, you see on the diagram, at the top you have sensors and actuators, things. We place them in the fields, we place them in vehicles, we place them on the body of a person, wherever, okay? Then you'll need eventually to have communication among the sensors themselves. Then at the network layer, you notice here you have what is called a gateway. A gateway, it is a gateway that do the linking between your internal sensor networks to the internet. So the gateway will do this this bridging for you. You can see on the diagram here also, there's a gateway that connect to the internet, and eventually all my data, in all IoT system, you will notice, eventually your data go to the cloud, which is on the over the internet. So whether it is Microsoft Azure, whether you're using IBM Bluemix, all these are platform. Whether we are using Amazon also has got its platform for IoT. IBM has got its platform for IoT. Microsoft has got its platform for IoT. They all provide what is called a cloud platform where you can transmit your data. Okay, all your data goes on a cloud platform. Then when you implement, for example, a mobile application, you pull the data from the cloud platform. So this is typically in your head, it should be very clear. We have our sensors, they capture the data passes through the internet, goes to a cloud, and from the cloud we do all our analysis of the data. We capture the data and then we display it on our mobile phone if we have a mobile application. The mobile application normally do not connect directly to the sensors. The sensor connect to the internet, goes on the cloud, then cloud will pull the data there for our analysis and for our use. Let's continue. Okay, so I've already mentioned to you sensors. Sensors mainly sense from the surrounding environment. Okay, you have different types of sensors: passive, omnidirectional. That is, it senses all around in the environment. For example, a mic captures sound from anywhere the sound is coming, it captures it. Passive, narrow beam. Passive narrow beam, it is the sensor capturing a specific direction, because the direction matter here. PIO presents IO a sensor that capture whether a person is coming from is in front of a door, for example. So it is specific to a position. And then you have active sensors like sonar, radar. So all these are different types of sensors. And then obviously I have told you about actuators. They mainly output to the environment. For example, switch on a light, switch on an alarm, start a sound. So these are normally done by actuators. Display message on a display board. So these are mainly done by actuators. And obviously, what is these things in the Internet of Things? Everything together, your sensors, your board, when you place it somewhere in your environment, this becomes the thing. Your lorry, your bag, your chair, your table, whatever you're putting your sensors, this become the things. This is why we say Internet of Things, because computers being placed on different things. So it can be placed on practically anything now. Even in your shoes, you may be having computers being placed. That is a microcontroller with some sensors and everything being placed inside your shoes, for example. This is why it is called the idea of things there. So a thing generally consists of 4 main parts. That is your IoT module, your sensors, actuators, the microcontroller, the communication unit, and power supply. Obviously, if you need to do some operation, you need to provide some power supply in terms of battery or whatever. So any IoT module will consist of those 4 components: sensors, microcontroller, communication unit for transmission of data, and your power supply. Okay, so most of the things, they're battery operated. This is why one of the main consideration in this module, you will see in other chapters when we are going to discuss, it is always a matter of energy. So as sensor students, have this at the back of your mind. We are dealing with small energy constrained devices, and we should always save energy for for those sensors. So it is generally small in size, low in cost, because those sensors are becoming very cheap. So you see my last point here, power consumption is the main design issue. For all the protocols, for all the consideration that we have to take on board there, you have the issue of a power consumption. So you need to have this always in the back of your mind. Let me continue. Okay, another part of the, so you see here, we are doing the different parts here, sensors, the thing, the communication now. So at the end of the day, when the sensor has captured the data, they need to somehow transmit it. This is why communication technology becomes important, whether you're doing Bluetooth, Wi-Fi, or whatever. Okay, so you need to communicate the data, and obviously we talk about wireless. It's very rare that you will have wired communication when you have deployed sensors in your vehicle, in the sugarcane fields or whatever. You won't be having wires there. So at the end of the day, you will need to explore wireless communication, and this is where, for example, Wi-Fi is a possibility, but you know the problem with Wi-Fi. This is where a NFC near field communication or Bluetooth it comes into play. But all these wireless technologies, they use what is called, I guess, in your wireless module, mobile and wireless module, you're going to learn about RF communication. This is what we use basically. Whether it is Bluetooth, whether it is Wi-Fi, whether it is any other technology like Zigbee. Zigbee is an RF technology. So they use what is called radio frequency to transmit wireless. And you see a popular RF communication solution. You notice again it is IEEE 800.15.4. This is what we use mainly. Okay, for our sensors. Obviously, IEEE 800.11 is Wi-Fi. Okay, Bluetooth is 800.15.1, and we have near field communication. All these are RF communication solution, and most often your sensors uses these communication technologies. Let me continue. Okay, and then eventually your sensors, very often they need to communicate with each other as well. Not only communicating to the internet eventually, but communicating to each other to share information. One sensor transmitting information to another sensor. So when your sensors communicate with each other, they form what is called a sensor network. So you need to form a network among your sensors. So network or a distributed system. So RF-based network in IoT. So they use what is called wireless multi-hop network most often. So there are different terms that have been used for this type of network. I mentioned last week wireless sensor networks, or mobile wireless ad hoc networks, MANET, or wireless mesh network, vehicular ad hoc VANET. VANET is vehicular ad hoc network. When your sensors, you place it on vehicles, then vehicles communicating with other vehicles, they form what is called a VANET. So there are different terms that are used, but these are just to tell you that your sensors communicating with other sensors. And obviously, main concern when you form those networks is reliability and performance. Especially, when you have bigger issue, when it becomes more difficult, when your sensors, they are not in a static position. They are not placed in a sugarcane field and they remain there. When your sensors, they are placed on object that moves, on human, on vehicles, and then that object that move, then it becomes difficult to maintain your sensor network. So this also, mobility is an issue. So you see here reliability and performance. This is concerned when you discuss the network. Let me continue. Okay, obviously your data at the end of the day, as I have told you, if it remains local in your network, very often it is not useful, because you want to get access to your data from anywhere. So for you to be able to get access to your data from anywhere, at the end of the day, your data needs to go to the internet and eventually to a cloud platform. Okay, so this is cloud. A cloud is very closely related to IoT. So at the end of the day, your data, you send it to a cloud platform. So the internet serves as a wide area networking for local network. Your local network is your sensor network. Eventually, it sends the data to a wide area network, which is the internet. So, and last week we already mentioned the internet uses TCP/IP. This implies that things must also support TCP/IP. This is the biggest challenge we have in IoT. Last week I mentioned it. This week I'm saying it again. Okay, so the biggest challenge, how you make your sensor network communicate to the internet, which uses a TCP/IP. You see down here, these are the nodes communicating with each other, forming your local network. You notice here there is a gateway that allows communication to the internet. This is a typical IoT system will be like this, and inside the internet, obviously, you have your cloud platform where all the data are being stored. Okay, so the same thing here, but in terms of the protocol stack. Notice here at the start you have your things, where you have the 4 things after you contain your microcontrollers, your sensors, the communication, and the power supply. So these are the things, and they are already. You notice here I've already said it is 8.1.15.4. This is the technology that it is using at the physical and data link layer. Okay, then above obviously you have the other protocol. So these are the things that eventually in this case it communicates with your gateway. You notice your gateway here, and this communication is done wirelessly. Depending on the technology you're using here, the communication is happen wirelessly. It can be ZigBee or whatever that communicate with a gateway down here. Now have a look at the gateway. You see on one side there's 800.15.4. So the data comes in which format? It comes in a format of IEEE 802.15.4. But then for you to communicate it to the internet, here to the internet on this side, it needs to be translated. In this case, since we're using a wired network, you see here, a wired network, it is IEEE 802.3. What is IEEE 802.3? It is your Ethernet network, your wired network that you have studied in year 2, if I'm not mistaken. You have studied this. So this is your wired network. It communicate through cable to the internet. This is assuming that you're using a cable here. That is the gateway have access to a how do you call this cable? Those who have studied some networking, your level 2, you must have met it. Let me put a question to the class. The cable that we use here in in our Ethernet network, there's a name we give to it. Okay, we communicate through a card, a particular card. How do we call this card?
Network interface card.
Okay, NIC. Well, for short, it is called NIC, network interface card, right? Okay, so how do you call the cable? How do you call the socket where you plug this cable? Anyone? This is basic networking. You must have encountered it in your, I don't know, year 2, even year 1, year 2.
RG45.
Yeah, RG45. This is the in your laptop you don't plug your cable. This is the socket that you use. So this is RG45. Okay, and we connect to it, for example, copper wire, category 5, whatever those cable that we use. But the socket that we use there, it is called RG45. Okay, so here when we say IEEE 802.3, we are actually connecting a cable here, a RG45 a cable. Okay, so this is wired. On this side it is wireless, and this is the gateway I was mentioning earlier, and these are the things it uses IEEE 802.15.4. and on this side you see the server. This is over the internet, so no problem. My cloud, whatever cloud system, whatever, it will be on this side. So this is the protocol stack that we'll use in our IoT system. In the introductory lecture itself, I'm already discussing all these components, because in future chapters I'm going to discuss specific parts of this protocol stack. And you see the path that it follow here. From the sensors, it goes through the gateway. The packet normally translated from 800.15.4 to IEEE 800.3. Through cable, it goes to the internet, to a cloud platform somewhere on the internet. Okay, so again, this is more or less the same thing. The protocol stack, you can see at the data link layer down here, BLE, Wi-Fi, ZigBee Smart. These are some technologies that we use at this level, and you see 800.15.4 is there as well. You see this other network layer, we need to implement this 6 low wireless PAN, and then at the data layer, we have this COAP, MQTT, and everything. So more or less showing the same thing about the protocol stack. So as you get a clear idea that how the OSI layers of an IoT system, like what we're discussing here, the layers of an IoT system. And this is a summary of the different consideration here, the IoT solutions framework at different layers. What kind of technologies do we use? For example, devices, you see down here, Raspberry Pi, Arduino, whatever, and we connect our sensors, controllers, processors. These are the physical layer. At this layer here, our Bluetooth, Wi-Fi, RFID, our gateway, and everything we implement it at this layer. Higher up, for long distance communication. So this is for sensors communicating with sensors, but for your long distance communication, to connect to the internet, you need to do it. For example, you can do it for your 3G, 4G, whatever a network. Okay, you may have a middleware platform that do translation of data for you, management of data for you. Otherwise, above it, your IoT development platform itself. Which platform are you using for your development? Is it a Microsoft platform? Is it an IBM Bluemix platform? Or is it an Amazon Web Services platform? This is the IoT development platform. And then at the top, I have not talked about this one, but most often you have heard about data analytics. So very often IoT, since we monitor data, large volume of data, millions of data, so we want to perform analytics on those data, then we will call it what is called IoT analytics. And most of those platforms that I've just mentioned to you, whether it is Microsoft, IBM, Amazon, even Google, right? Google IoT, there is something called Google IoT. They provide you with a number of tools to perform analytics. So this is what is mentioned here, IoT analytics. And obviously at the top, your application, IoT application, your remote control application, your whatever application that your mobile application that you have implemented, it is at the top here. You see something cut across here. So this is security. Security is an important consideration in any system, and more important in IoT system. So security cut across the whole framework. Let me continue.